Sample problem 2303. The figure 23-10A, the one on your right, shows in cross section plastic spherical shell with the uniform charge Q minus 16E and the radius R 10 centimeter. Particle with a charge of 5E is at the center. What is the electric field at the point P1 at the radial distance 6 centimeter and the point P2 at radial distance 12 centimeter? So basically, this is typical problem using the Gauss law. So you have a point charge, which is a source of electric field that either just radially just create electric field outward, or if in the case of the minus charge, then the electric field is just, converts into this point charge as a sink. So in order to actually estimate the net charge across the Gaussian surface, you first have to set up the Gaussian sphere. In this case, point charge is sitting on the center of system. So your Gaussian surface must be the symmetrical shape, which is a sphere. So the first step for first question, you have to create the Gaussian sphere inside of this spherical shell, because point 1 is inside the spherical shell. In that case, electric field pointing outward, because the point charge at the center is positively charged, so that produces electric field outward. And spherical shell, inside the spherical shell, at the position the P1, the Gaussian surface should be like this, with the radial R. So with that idea, the R1 up to the point P1 has this kind of configuration. So this R1 is the radius of Gaussian sphere. And as I said, because this point charge Q is positive charge, the electric field is outward. And on the surface of this Gaussian sphere, aerial vector is pointing outward. So with that, area vector element should be radially outward always. It must be always outward from Gaussian surface. So as long as you have a Gaussian surface, you're sitting on surface that area vector should pointing outward. So and then here the angle between the electric field. So because of that, angle between the electric field and the area vector equals 0, because they are pointing that same direction. They all align in outward radially. So theta, angle between the electric field from point the positive charge and the area vector dA equals 0. From that condition, the Gauss law provides total quantity of net charge inside enclosed area. So that is given like this. So that's epsilon naught times electric field. Now dot product could be expressed with the cosine theta. So that is a cosine theta dA. Here theta equals 0. So that is equal to 1. So from that, electric field, this given condition is a constant value. So that could be out of this interval. So the interval of dA is same as surface area of a sphere, which is 4 pi epsilon, R square, radius of sphere. So there's actually epsilon naught. So that is the same as net charge inside of Gaussian surface. From that, electric field could be expressed with this notation, then Q point charge divided by 4 pi epsilon r square. That is electric field inside the shell. Now let's take a look at the electric field outside the shell. If you stay out of the shell, because this shell negatively charged, electric field should be inward. And now the area vector, as I said, on the Gaussian surface always outward. So angle between electric field and the area vector is 180 degree. So if you use that condition, number 2, if electric field at point 2 outside of the shell, so total quantity is like net charge inside of this Gaussian sphere include point charge Q and the shell of this sphere. So that is Q plus capital Q. Now his small q is 5e, and the shell is charged with minus 16e. From that, total charge inside of this spherical shell is minus 11e. By the way, that when this radius of Gaussian sphere is smaller than the spherical shell, then this Gaussian sphere only include the point charge in that enclosure, so that Q value should be 5e. So that is same as 5e 4 pi epsilon naught r square. So then now we have this one inside of this integral. So the electric field is minus Q. Oh, let me just fully express that. So the epsilon integral flux electric field EA should be same as Q, E, and C. And from that, this one should be electric field for, so that right now, that is integral of electric field cosine theta dA. Here theta is 180 degree. So that should be minus integral electric field dA. Here electric field still constant value inward. So that should be minus electric field integral dA. And this one is 4 pi r squared. So you plug that, then total amount of net charge is minus epsilon electric field 4 pi r squared is Q net charge inside of the Gaussian sphere. So electric field outside of the shell should be minus Q, E, and C enclosed 4 pi epsilon naught r squared. So as I said, this Q, the net charge inside of the Gaussian sphere include point charge Q and small q, and the charge of a spherical shell, which is 11e, I mean the 16 minus 16e, so total charge minus 11e. So that is minus 11e over 4 pi epsilon naught r squared. So the minus sign cancel each other. That leaves 11e times 4 pi epsilon r squared. So number 1, if you stay inside of a shell that contains point charge in the spherical radius of Gaussian sphere, the electric field is the 5, let me just rewrite it, 5 times E 4 pi epsilon naught r squared inside at P1. Now you plug all the value inside of this formula, then that's actually 5 times E 1.6 times 10 to the minus 19 Coulomb divided by 4 pi 8.85 times 10 to the minus 12 Coulomb squared per Newton per meter square. And the radius of the point 1 P1 is 6 centimeters, so 0.06 meter square. You plug them all, then that lead to the electric field of 2 times 10 to the minus 6 Newton per Coulomb. And now, second question, electric field is 11 E over 4 pi epsilon naught r squared is outside of the shell, at P2. Plug that 11 times 1.6 times 10 to the minus 19 Coulomb divided by 4 pi 8.85 times 10 to the minus 12 Coulomb squared per Newton per meter squared divided by the point 2 is the 12 centimeter apart from the center of the sphere, so that is 0.12 meter square. So from that, electric field at point 2, P2 is 1.1 times 10 to the 6 Newton per Coulomb. Okay, that is answer for 2303.